All right, so it looks like my audio is not working on this, so I'm going to try. It's going to be weird because you're going to hear me talking, but I'm kind of doing something else on the screen. But you're not going to do 11.2 for today, but you're looking down here at 11.3. I'm also going over the Are You Ready for More currently, um, and so that Are You Ready for More? You're going to be able to do. Looks like I'm going over the fact that the cube root of 2 is close to 1.25, and we know that 2 cubed is equal to 8. So we're going to make our estimate there, and we're going to try and explain why Mai's estimate, how she got it, and how exact it is. So if you wait for me to start to go over it, because I don't want to talk before I do something, it looks like we're looking at 2 1/3. And the reason we do that is because that's the same as the cube root of 2. And so we're kind of explaining what Mai did. So 2 1/3 is 1.2. We know that. And if we were to multiply that by 2 cubed, that's the power, multiplying like bases rule. So you're going to add that 2 together, and that gives you that 2 to the 1/3. Back here where I was looking at, I know it's going to be weird because you see my mouse and you see the pen, but that's going to be 8 plus 1.25 because that's what she said, and that gives us 9.25. And we know that log base 2 of 10 is roughly 3 1/3, so it's pretty close, right? 9.25 is pretty close. Not exact, but pretty close. So that's where we were able to get that from. Waiting for me to finish my explanation here. Same of what I just said, right? It's less than 10, but it's close to 10, so something close there. When we do this 11.3, finding logarithms using a calculator, I think I'm reading it off, so I'll read it all for you. It says to solve the equation 10 to the m equals 19. Oh, nope, doing something else. 10 to the m equals 19. Tyler writes the equation for the logarithmic form. M equals log 10 of 19. Then he presses the log button on the calculator, enters the number 19, and writes down an approximation of 1.279. Pyra follows the same steps in her calculator and writes down 1.27875. We want to experiment with your calculator and understand how to evaluate log base 10 of 19. So you're going to put this into your calculator. Remember, it's not log base 10 works in the scientific calculator on Desmos, which I'll show you here in just a second. It'll also work in the graph, but let's just go ahead and do it in the scientific. So you hit function there that I'm pointing to. Go over there. I'll move my picture here in just a second. But you come over here and hit log, and then you get log, and it's automatically base 10. So we'll type in 19 here. And then you're going to get 1.278753602. You're not going to want to put all of that down. It does say approximate. So you're going to approximate exactly what you want. And wait for me to go back to the other page. So let's see, 1.2787. Oh, I'm going to write them all down. 1.278753601. Come on, me, catch up. And you can write that out kind of just like that. So discuss with a partner, why might log base 10 of 19 be expressed in different ways? It's all about like the different ways in which you find that expression. So if you were to not use your calculator, or if you were to use your calculator and you did different rounding, so we could round differently. So maybe one person puts 1.3, right? Because that would technically round to 1.3. Somebody else puts 1.28. Somebody else puts 1.289. Somebody else decides to put exactly all of that as it is. Then you'll just, that's different ways that it can be expressed. And it's all about rounding. Number 2 underneath there, it says express the solution to each equation using a logarithm, and then next find the approximate value of the solution using a calculator. So this goes back to around the world. So that's going to end up being log base 10 of 24 equals m. So you could also do this kind of guess and check game. I think that's what I was doing here, where you're going to put 10 to the power of, and you start guessing. Like I know I'm looking for something, so I'm going to do log base 10 of 1. That's not it. Log base 10 of 2. Oh, I noticed that the number I'm looking for is between 10 and 100, so it's got to be between those two. Or, all right, so I'm going to try log base 10 of 1.1. How about 1.2, 1.3? Now I'm getting closer because I wanted it to be 24. It's not quite there. So that's one way to guess. But because we want to do a logarithm, we can do around the world and do log base 10 of 24. So I'll let myself write that really quickly. Now that can be placed straight into the scientific calculator because it's base 10. So log base 10 of 24, type it all out, it's 1.38. So when we did our guess and check game from before, we got close. And we could just, I think I'm just going back to show you exactly how close we can get. All right, let's do, oh, I'm typing it out. M equals 1.38. Probably explaining how you can round it. All right, now let's do another log. If it's 10 to the n equals 750, do around the world again. Looks like I'm doing a nice little guess and check once more. And you can see what we're looking for, right? We're trying to get close. We're doing a guess and check. I'm just changing the decimals after the fact until I can get close to 750. So it's going to be something close to 2.875. But if we do that around the world, like what we said, that's going to be log base 10 of 750. Remember, you don't have to put the base 10. You can just put log of 750. Now, when we type that in or we write that in, whatever, you can just, as you see it, 750. And it looks like we got pretty close. I got close from before. So 2.875. Ooh, look at me continuing to do those rounding. That's great. All right, last one here is the estimate. Estimate the value of each expression. Explain to a partner how you made that estimate, and now check your estimate with a calculator. So this is log base 10 of 90. And since it's log base 10 of 90, we know 10 to the power of 2 is 100. So it's got to be between 1 and 2, the power. And it's closer to 2 because 90 is closer to 100. So we're kind of thinking this is going to be somewhere between 1.1 and 1.2. I'm sorry, 1.9 and 2.0. So I'm guessing here that it's going to be like 1.91. And then I come back and I check it in my scientific calculator, and I put 10 to the power of, oh no, look at me putting in the log. So log of 90. So it's 1.95. So I was close, not quite. So we know that's 1.95. Now remember part B there, it says log of 1005, and that is close to 1,000. So we know that log, or 10 to the power of 3 is 1,000. So it's really close to 1,000. In fact, it's only 5 units away. So it's probably going to be just above 3. I would think that it's probably like 3, let's see what I thought, 3.0. I was going to say the same thing. Good job, me. 3.001. So that's just an estimate because it's so close to that 1,000. So I think I'm typing it, or 10 to the 3.00. Look how close that was. I think I started playing around to see how close I could get after that. All right, go ahead and type it out. Log of 1005. So 3.0021. So that would be the answer to that one. That's the exact answer I'm writing now. Okay, the last one is log base 10 of 9. So that's under 10. So in that case, you're going to get 10 to the power of 1 is 10. So you know it's under 1. So really something close under 1 is 0.9. Now you could start playing with the numbers after that. You don't have to. That's a guess right there. That's an estimate. As long as you're close to that, that's fine. So then I think I just go ahead and type that out, log base 10 of 9, and that's 0.95. So that's really, really close there. I think I end up writing that out, telling you to finish all the recordings there, or writing it out and then uploading it. So please do that for me, and I'm sure you'll get